Yeah. Yeah. So, hello? 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 Can you able to hear? Hello, students?
Yes, sir.
Yes, sir.
Yeah, yeah. Good. Okay. Yeah. So, any questions so far? Yeah. Okay. And so, first of all, actually, this direct and indirect communication we are discussing about. So, in case of direct communication, there are some issues, right? There are certain issues with the direct communication. Like even though it appears like if you have provide the use the names directly and they can have communication without help of any intermediary thing and all. But the problem with that actually, if you just go with the names and then if you want to change the names later on, actually, then all the attributes of a process need to be changed, and it's like almost like a performing the doing the coding with the kind of hard coding kind of a thing. So usually in that aspect actually the direct communication is not usually suggested. So people use like mostly the indirect communication where take the help of the kernel created mailbox and with which the process can communicate. And yeah, here these are the various scenarios. For example, as you've seen, the mailbox can be shared by multiple processes like P1, P2, P3. They can share the mailbox here. And suppose the P1 sends and P2, P3 can receive. Like here, how they coordinate and all, like who gets the message, like who, how to coordinate. Suppose, for example, the message is targeted only for P2, for example, then how do you go about it? Because the mailbox is shared by multiple process, and if you target the message to a specific process, then how do you target? How do you handle that? Like so, there are various ways the you can handle that. One thing is that allow a link to be associated with only two process. That means a mailbox can be shared to you can keep a limit that a mailbox has to be shared by only two process. So at that time, there won't be any issue at all. But it's not that like that. And suppose allow or otherwise allow only one process to receive at a time. It means that suppose P1 is sending, but whatever the contents were there in the mailbox can be captured or can be received by either P2 or P3, like only one at a time. Or otherwise, if you want to restrict that only P2 has to access, then you can also specify that like the P2 can access the mailbox alone or only not the P3 and all. So that way you can able to do it with appropriate ways. You can able to handle the communication between the desired process and all. And then yeah, then another thing is that synchronization means that here when you are passing the messages or when you are sharing the messages or data between the two processes, so how that the sharing can happen, how the data transmission can happen, there are like various ways. Like one is that synchronized way or asynchronized way, and the one whatever we have seen the using a mailbox and all, so it's a kind of asynchronized way of data transmission. It means that whenever you have a data, you are sending to you are just passing to the mailbox. And after that, the receiver will again just check the mailbox and then it will receive that one. It's not that the sender is sending and receiver is receiving at the same time and simultaneously. It's not that way, right? So it's nothing but it's not to be like asynchronous way of communication, right? And there are ways like synchronous communication and asynchronous way of data transmission. In case of synchronous way of sharing the data, it means that the calls are the methods that are used for synchronous way of communication will be blocking with the help of blocking. It means that for sending a data, the sender will use the block send or block send system call. So it means that sender will send the data and then just waiting until the message is received from receiver saying that the message has been received by the receiver and all. So till that the sender will be blocked. That means after sending the message, that means by using this particular system call that like blocking send system call. So with that, the sender will send the message to a receiver, and then the sender will be blocked until he receives the acknowledgement from the that acknowledgement will unblock this system call. So with that, the sender will come to know that, yeah, the message has been properly received. And similarly, the blocking receive. So blocking receive is also, receiver is blocked until a message is available. That means receiver will execute this, will invoke this blocking system call, blocking receive system call, and then with that, actually he will just waiting for the message to receive. Whenever the message received, then it will unblock and then the message will be received. Otherwise, it just keep on waiting for a message to be received. So this is not to be like a synchronous communication where the sender and receiver, by using a blocking system calls, they can send and receive the messages using that. So here in this case, blocking send and blocking receive, there is no need for any buffer is required and all. The sender is sending and then the message will be sent, and then the sender will keep on waiting for that. And then after, whenever he receives the acknowledgement, then he will be unblocked. And similarly, the receiver is also will, by using this receive block system call, and he just waiting for message to arrive from a particular sender. And when the message arrives, at that time, it will be received. It will be received and it will be unblocked. In case of non-blocking, it's going to be asynchronous, whatever I just mentioned. Example is that using a mailbox or whatever. In case of non-blocking system, here send, where the sender sends the message and then afterwards he will continue. He will come out of that and again he can carry out some other work, and he can again try for sending the next message and so on. That can be done. And similarly, receive also. The receiver will just attempt to receive a message. If there is a message, now then he will pick up the message. It's going to be valid message has been received. And if there is no message available, then he will get a null message and all. So that way, this is going to be non-blocking receive, non-blocking send, and non-blocking receive and all. And whereas in case of non-blocking receive, if the message is available, then message will be received. And if it is not there, the null message, it means message is not there and all, right? Then after some time, then again you can able to try. So that way you can have non-blocking send and receive, the one whatever we discussed in the previous slide and all. And there are different combinations may be possible, like blocking send and non-blocking receive, or different possibilities can be done. And here, as I mentioned, that if both parties, like both the process, if they execute or if they use this blocking send and receive, then we can say that it's like they are linked by using these residues. It means that there is no buffer is required and all. So whatever you transmitted, it will be received. If it is not transmitted, the receiver will be waiting. And even the sender is also, like after sending, if it is not received, or if the receiver is not there, a receiver is not executing or not invoking the receive system call, then the sender will keep on waiting and until the message has been properly received. And these are the ones, like whatever the blocking system calls, whatever I just mentioned for sending and receiver. These are the very simple implementations, right? So as long as the sender, that means here by using this system call send, whatever the next, it's in the producer consumer problem. If producer and consumer problem, if they use these blocking system calls, then both will be just keep on waiting till the sender, the message whatever is sent is properly received. And if it is at the receiver side, consumer side, if the receiver is waiting until the message has been arrived, the receiver is keep on waiting for the message and all. And the buffering, as I mentioned, and here buffering is nothing but it's like a part of that establishing a connection, or in the scheme of establishing a communication link and all. So zero capacity is nothing but the first one, the blocking scheme. That means if you are using a synchronous transmission, like blocking send and blocking receive and all. So in that case, it's not to be zero capacity. That means there is no need for any buffer, or any intermediate buffer is not required. And the bounded capacity means the one whatever they're having a mailbox, and then the mailbox can have certain size, certain buffer capacity. And till the buffer fills up, you can keep on sending the messages and all. The sender will be unblocked. And if the buffer is full, then the sender can be blocked. Sender will be blocked because the buffer is full. So whatever the message you want to send, he has to wait till there should be some empty space in some space in the buffer. And unbounded capacity means, as I mentioned, like it's not the practical scenario, but the kind of applications that you are using with respect to the given buffer capacity. So that can be viewed as unbounded capacity, where in that case, sender need not be bothered. Sender will be like always use the unblocked send, because whenever he attempts to send something, always the buffer will be available. Then there is no need for to block. And now you can see here these are the examples, like so far we discussed about the way the interprocess communication takes place using shared memory and using the like message passing scheme using a mailbox and so on. Now we'll see some examples like how this implementation will be done, or what are the system calls so that were used for handling this IPC through shared memory or through message passing and all. And here first we discuss about the shared memory, and for supporting the shared memory, the Unix system where it supports using a POSIX API, with it supports these system calls, and these are the API, the functions supported by the POSIX, where, for example, by using this API, we can able to create the shared memory segment. And not only creating, if the shared memory segment is already created, then it can also open. So that means the same API can be used for creating or opening the available shared memory segment and all. Like SHM open and the name of this one, and create when if you want to create a fresh shared memory segment, then this using this create you can do that. Otherwise, the read write operation, that means whether the shared memory segment is for reading purpose or for writing purpose, and these are the like access permissions kind of a thing. So by using this particular like API, so one can able to create a shared memory segment, and the same thing can also be used for opening the shared memory segment also. And after creating a shared memory segment, here this is a shared memory segment, is kind of a file descriptor, like it's kind of a file where some logical space will be attached to that, and in that logical space, memory space, where the different process can share that, can access that, and with that they can able to communicate. So therefore you can see this is a shared memory file descriptor, because it's a kind of a file, logical file. They haven't given some space and all. That space is again given by the space allocation to the shared object, this shared memory object will be done by using this particular system call, by a particular API, ftruncate, SHMFD, comma, SHMFD is the file descriptor associated to this particular shared memory. And this gives you this defines what is the size of the object. That means how many bytes of memory you require for carrying out the data transmission between the process and all. Here this is a 4K memory space is being allocated to this particular shared object and all. This is a kind of shared memory segment is created, and afterward the size has been set as a 4K. And once it's created and size has been set, then afterward this shared memory segment has to be mapped to a process which want to communicate, suppose P and Q want to communicate, then the P, by using a memory map, there is a command, we'll see that in the next slide and all. So with which you can able to map the shared memory object to its address space. And likewise, a Q want to read the data from that, means again a Q also will map its address space to the shared object, and then with that it can able to receive the data or can able to read the data and all, right? And afterwards, once the mapping is done with respect to by using for the processes and all, then after that by using the appropriate functions like system functions, one can able to this one sprintf, you can able to write into the shared memory, right? You can able to write into the shared. Suppose this is the string you want to write into the shared memory, you can write into this one shared. This shared memory is nothing but you can see, as I mentioned, like once you map this shared memory object to the process, and that will return a pointer, and that pointer indicates the starting address of the shared memory and all. So here this is a pointer. So with that pointer you can able to write into the shared memory object and all. And these are the kind of, like you can say that the APIs with which you can able to create a shared memory segment, and you can able to access the shared memory segment. And so yeah, this is the code, very simple code, where you can able to see that later on. This is given in the textbook and all. You can say that here the size of the shared memory has been given, the name is given over here, and what are the strings that need to be passed to the to other process and all that are given as message 0, message 1. And you can see that this is a file descriptor shared memory. And then once the shared memory object is created, then afterwards you can see that, yeah, this is created one, SHM open, right? And then the size is specified over here. And you can see here mmap. This is again the API, that is a function support to call the system. That means call the system call with which whatever the process where it want to map the address space to here. So that will be done over here. So here for writing purpose, and you are mapping shared memory, you are mapping, and then the pointer will be written. You can see the PTR, and with which this pointer you can able to write or you can able to read also. Here for writing purpose, so therefore we are using sprintf, and you are writing with the help of this pointer, like message 0 you are writing over here. Then afterwards you are updating the pointer. Then at the updated pointer again you are writing the next message, message 1 you are passing. So likewise you can able to, this is a producer side. A similar one at the consumer side also. At the consumer side, that means you have a producer is nothing but just writing a data into shared memory, and a consumer's job is to like reading the data from it from the shared memory. Again, he follows the same thing from a consumer side. Again, you can see that the size and all these things has to be defined. And again, because already the shared object is already opened there, right? So already there, already that shared memory is already created. So therefore now here just we are opening that the same function call, but here we are not meant for creating, here just for opening that for reading purpose, read only, right? And afterwards, after you open that, then you have to map these to the corresponding consumer, the consumer. And so mmap you are using, and here for reading purpose, and you are sharing this to the this consumer, and it returns the pointer and all. That means the address of the shared memory. And then with the pointer you are reading. With the pointer you are reading the data. So once the job is done, if you want to remove the shared memory from the process center, suppose the process communicate, then the communication is done. Then afterwards it want to delink the shared memory, that you can do it with SHM unlink name. So with which you can able to again, like you can like whatever the shared memory that is created, that can be removed. That can be removed, right? So that way the producer and consumer can create a shared memory, then access the shared memory, and then with that the producer can write something into that, and the consumer can read from that. Okay. So that is a shared memory, IPC through shared memory. And the same thing in case of this match operating system, match operating system, where as you know that this match operating system is a microkernel based, right? It's a microkernel based. So it means that here the entire communication and most of the this operating system tasks will be carried out in the user domain, but all those processes will communicate through kernel and all. That's what we have seen in the case of microkernel. If you see that all the things like even the device drivers, even the other the memory management tasks and all, and even the file access, everything. So that will be done at a user level, but the entire communication will be done through the operating system to ensure the security and other things. So so therefore the operating system will perform the communication through the message passing scheme. So therefore here it uses these system calls like message send, message receive, and message RPC. RPC means a remote procedure call. That means message send and message receive. These two system calls are used to send and receive the messages, a process that are present in the same system and all. And suppose you want to communicate a process that is not present in the system, that is somewhere in the other system, remotely it's present through network. So at that time, you can use this particular system call with which you can able to either you send the message to the remote procedure call, right? So these are the different system calls that are used for message transfer. And for creating a mailbox, you can use this port allocate. As we have seen that the mailbox is designated with certain port number, some integer number, some integer value and all. So that that mailbox is created using this port allocate, because you see that this is the Mac operating system is the here the communication or the inter-process communication is carried out by using the message passing scheme. So if you want to perform message passing scheme, as we have seen that like either direct or indirect way of establish the links, and you need to communicate through that. And for that, actually, you have to use the operating system has to be involved. That means there is a mailbox has to be created. And once the mailbox has been created, then through the mailbox, the process will communicate using message send and message receive and all. Right. So these are the system calls that are associated with that. And then anyway, if the mailbox is full, then what are the various like ways you can access that? Like how do you do that? Suppose because the mailbox is a finite memory buffer and all. So if the mailbox is full, then how do you interact with that? There are different possibilities were mentioned over here and all. That means wait, you block it. Wait indefinitely means if a mailbox is full, you have to block. That means until a mailbox is available, or otherwise there are other options like periodically you can check it out or keep it in somewhere in the cache or something. So these are the different possibilities. And then in case of Windows operating system, like the processes will communicate using again a message passing scheme. But here in case of Windows operating system, the message passing, or you can say that the process communication within a system is carried out by using a local procedure call. Using a local procedure call, it means that it's calling a function call, and with which the it's kind of API, and with which the communication will take place. That means whatever you want to send, you can able to send through the desired process. Similarly, if you want to receive something, you can also receive that from the desired process and all. And for performing that, here it make use of ports. It make use of two sets of ports known to be connection ports and communication ports. You can see here. Here, suppose for example, here both are there in the same system. It's a client means the process which want to communicate to some other process. And here there are some operating system modules that used to help for performing a communication between the different processes and all. Suppose a particular process it want to communicate, it needs some information, information has to be sent, or some information has to be received from some other process, for example. First it will initiate, so it's not to be client here, and it will initiate using a connection port of that particular operating system routine, right? Because the operating system, because the system where the operating system used to maintain a process. This server is nothing but a process where this particular process used to coordinate the communication. It used to help to perform a communication between a process system, user process in the system and all. So the first the user process will initiate, because the user process will be aware of that what is the port address of this particular server and all. So with the connection port address of the server, it will initiate the connection, and then once the connection is established, then it sends the request. It sends the request to the server and all. Server is nothing but it's a process again, and then the server will initiate, will prepare, will give you the, will provide the a pair of communication ports. Will provide a pair of communication ports, and with this pair of communication ports, the information exchange will take place. Suppose the messages need to be communicated, and also then the client can send the message using this communication port, and the server can able to use this communication port. It can able to perform the communication between these two communication ports. First, actually, the client will initiate a connection using the connection port of the server, and then the server will derive two communication port addresses, and they will provide the handles to corresponding process and all. And then these two are the handles. So with these handles, that means with these handles means with this, the client will communicate to the server, and the server can able to communicate to the client and all. So with these port addresses and all. And if the messages are smaller, then by using these communication ports, they can able to communicate. Suppose the message is larger, for example, the message size equals to more than 256 bytes and all, right? So at that time, there will be a lot of delays involved, because the message will be sent only with a fixed size. So therefore, if the size of the message is larger, for example, then they need to be split it into pieces, and several times it need to be sent, and several times it need to receive and all. So to overcome this, the burden or the overhead, so here at the time of when the client is requesting, at that time the client will specify that what is the size of the messages it need to be expected to send or expected to receive and all. So based on that, the server will initiate instead of, if it is a smaller messages and all, then it will derive a communication ports, and with the communication ports, the message transmission can be carried out. If it is a larger message, then the server will create a shared object and it will return the pointer and all. It will return the pointer. So with the pointer, the client can able to client can able to access the shared object. So with which he can able to write or can able to read from that. And if the object is, if the data size is much larger, at that time the server can directly access the client's address space itself. If the data size that need to be transferred, suppose the client has asked some file. If the file size is very large, suppose if the file is a kind of image kind of a thing, it's an order of megabytes and all. So at that time, instead of creating a shared object, the server will take the control of the client's address space, and then it can directly read the contents in the client's address space, or it can directly write into that also. So that way the delay can be avoided, and the overhead is also can be reduced and all. Right? There are, like, if it is a normal data size or the messages of smaller size, then by using these communication ports or using send and receive system calls, it can be carried out. And if the size is larger, then the shared object can be used. And if the size is much larger, then at that time, usually the client is requesting, means actually requesting the data or a file or some facility from the server. So therefore, the server will just will get the access to the address space of a client, and then directly either it can read from the client or it can be write into the client's address space directly. It can be done. Yeah, so far we have discussed about all these things, whatever we discussed. So these are mostly we discussed about the IPC in the context of a process that are present within the system, within a system and all, right? And suppose there are occasions, there are lots of applications where a process need to be interact, and where those processes are not present in the system, or not both the process may not present in the system. A process want to communicate a process in the remote machine. Like for example, simple ones, whatever the most of the applications, whatever we are carrying out, what we are doing, mostly with the communication between the remote process and all. Like for example, when you're accessing a web server and all, using a web browser and all, so that so the kind of a communication will be the process interprocess, the kind of communication between the process will be like it's like a remote. The processes are remote. It's not that both the processes are in the same system and all. As a web browser, it's the process is present in your system and then in your desktop. And whereas when you're accessing some web server or some other system, database server or a file server and all, and that particular server, that process is not present in your system and all. It's there in the remotely located somewhere in the server and all. And then you are communicating with that. So, so here these are the different possibilities, different ways you can able to perform a communication between processes which are remotely located, which are not present in the same system. You can say that. So the methods that are used will be, one will be the sockets. We'll discuss about what is meant by socket and all. The other one is the remote procedure call, and the other one is the pipes. And then using in case of Java, by using a remote method invocation, you can do that. We'll see one by one. A socket means, for example, we have seen the client server configuration. We know that at a broader level, what is the scenario? It means that there is a process in one machine. It tries to communicate with a process in the remote machine. For example, web browser and a web server and all, right? So a process that is in the one machine, and to identify that process, the process will be identified by the host name and its identity. It's not to be port number and all. Here you can see that there is the process. Suppose the process is present on your desktop. So your desktop happens to be a machine, or not to be host and all. And on this machine, there are several processes present in your system. Maybe you are activating web browser, and suppose you are doing some word process also you are running, and suppose you are doing some other thing, and you are accessing some other one. So all these becomes a process that are present in your system and all, right? But all these processes are there in your system, in the desktop. So therefore, the desktop is identified by the host ID. Is identified by the host ID. This is also known to be IP address of the machine. IP address of a machine. So IP address means it's like a host identity or like a machine identity, right? And within the machine, there are several processes are running. And to identify the each and individual process and all, we'll make use of another identity is required. So that was nothing but here. This is here that is indicated by a 16-bit binary number and all. So that is known to be that is also known to be port number and all. So these two together can able to identify a process uniquely and all. Uniquely. That means you have web browser on this desktop, and maybe you have some other you have some other desktop, some other machine was there, and there also you are like for example, you are using a web browser and all, right? And in the both the cases we are using web browser, but the machines are different. So therefore, like each of the process will be uniquely identified by a combination of host ID or known to be IP address of a machine and concatenated with a process ID. A process ID, it's not to be port, not to be port. And so that way, a process want to communicate with the remote process. So these two process, that means a process at your system and process at the somewhere else and all. So these two systems will establish a connection by using these unique IDs and all. So here, the concatenation of or a combination of the host ID and the process ID together is known to be a socket and all. Here the socket is nothing but the unique identification of a process, right? It is nothing but the process ID will be there. Along with that, the process is present in a particular system, particular machine. So the machine has certain ID, IP address. So therefore, the IP address with the process ID are known to be port ID, and these total tuple can be viewed as a socket and all, a socket. So maybe, for example, you have a browser and also the browser has some port address will be there, and the port address and the IP address of your machine together will be viewed as a socket. And likewise, you have a server, you are try to contact a server, web server. From that, you need to fetch a page. So the server's host ID will be host ID, and whatever the web server is there that has a process that has some ID will be there, a process ID. That two together will become a socket at the destination socket at the other end and all. And now the communication, the connection established between these two sockets and all. Socket you can see here, for example, and this is a socket, right? This is a host ID 146.86.5.20. This is a host ID or IP address, right? And then the 1625 happens to be your port number, and together is known to be socket. And here again 161.25.19.8. This is the host ID, and 80 is your port number and all. So usually the web servers, because these are the very well-known services that is offered by various servers and all various applications. So these well-known applications, like for example, web service, web server and all, HTTP protocol, and for example, file transfer protocol, and remote login. Like suppose you want to log in from some other machine and a remote and all. So for that, you need to have some process ID, specific ID is required. So likewise, the email applications. So these are the very popular services which need to be performed, which need to be used very frequently. So for these popular processes or proper services, so they have been given a specific process ID, not specific port numbers, and these are known to be well-known ports and all. Usually, because as I mentioned that this address, the port address will be maintained by 16 bits and all. So 16 bits means how many, like you can have the range of 16 bits will be like a 0 to like 2 power 16 minus 1. 2 power 16 minus 1. So that is a range. So you can, the process can be identified by process number can be given, the port number can be given anywhere in that. But some of the popular services, so for uniquely identifying that, so these popular services will be given the port addresses that are reserved. The first initial 1000 addresses, 1024 addresses are reserved for these well-known services, whatever I have mentioned, like email address and, for example, file transfer protocol or remote login and yeah, something like web browser or web server. So for all these things, you will give some whatever the port address will be there. That port address will be same across all the machines and all, but they are distinguished based on the on which machine you are accessing, on which machine you are accessing a web server and all, because the web servers, they are there at several places and all, right? And each web server will have the same port address will be there, maybe 80, but that web server will be located in a particular server, particular machine, and that machine has some ID will be there. So that particular ID together with that port address, so that will be unique. So that way here the sockets, that means these unique IDs will be there. So with the unique IDs, using the using the appropriate network protocol, first the connection will be established. As I mentioned, like whichever wants the actual connection, that becomes a client and all, and that will initiate a connection, and then the server will be keep on waiting for the connection. It just listens to it will be blocked with the listen primitive, or with the listen because the server is meant for providing services to the host, providing services to all clients and all. So whichever client requests for a server, then the server will be unblocked, and then it will establish a connection. It will send a reply indicating that the connection has been accepted. And then afterwards, the client will send a request, whatever it requires from the server. It sends a request, maybe requesting for a particular file or particular web page and all. Then the server will just extract that particular web page, and then it will return to the client. Then if that is the only thing that is required by the client, then afterwards the client will request for connection termination. Then the connection will be terminated from the both sides. So that way, the client, whichever wants the service and all, it will first establish a connection. Then afterwards, through the connection, whatever it sends a request, it get the reply, and then afterwards, once the whatever the data communication that is required between the client and server, if it is completed, then it initiates the terminating a connection and all. So that way, using the sockets, the process communication, the communication between the process can happen remotely, where the processes are located and the remote machines and all, right? And yeah, here for establishing a connection, maintaining a connection and all. So these things will be handled by the network protocols like a TCP protocol and all. So that with that, the connection will be established. Once the connection is established, then by using these like send and receive system calls, like then with that you can able to send the message and you can able to receive the message and all. So that way you can we can able to perform the communication between a process which are located on the remote machines and all, right? And yeah, this is the one. Yeah, this is the just simple code where how the the server is waiting for connections and all. Then afterwards, how the server will write into that, will send a reply. So these things you can able to see this particular code. It's very simple, right? And here these are the different types of sockets, as I mentioned, like a connection-oriented socket, connectionless socket, multicast socket. It means connection-oriented socket means here. First of all, the client and the server and all, they will communicate each other and they will come to know each other, what are their IDs, everything. And then afterwards, both will agree to a connection. And then through that connection ID, the messages will be communicated back and forth between client and server and all. Whereas in case of UDP, not to be user datagram protocol, and here there is no connection at all established. Just simply the client will send the data, will send the packet to the server, saying that I need some information. Maybe that information that is required will be very small, very simple information and all. At that time, the client will just send the data will send a packet where the packet itself, it contains it indicates that what it is required and all. It will send the information to the server and all. And when the server receives that packet and all, then it will see the packet from where it is arrived and then what is the request and all. So based on the request, if it can do something, then it will send the reply. Then it will whatever the information requested, that information will be placed into a packet, and that packet will be sent back to the client. Sent back to the client. Here in this case, there is no connection is established at all. Just a packet has been sent, and then the reply packet has been sent. Request packet and the reply packet. That's all. Whereas in case of connection oriented, before sending the request and reply, first of all, the connection has been established. Here, the connection is not a physical connection. There is a logical connection that will be established with certain unique ID and so on. And later on, after establishing a connection, then the data transmission will happen through that connection with that particular ID and all. So this is a connection oriented. This is a connectionless. Multicast means actually here using these multicast sockets, you can able to send the data to multiple multiple recipients. That means, for example, you want to send the data to the multiple hosts, for example. Then by using this particular socket, with that, you can able to send the data to the multiple clients, a group of people, like with a single transmission itself, right? So this is a multi-socket thing. But anyway, yeah, this is the one you can, if you just go through the code, then you can able to understand like what is the server part and how the server will respond and so on. Then there is another one way, a method with which you can able to access or you can able to communicate with the remote process and all. So this is going to be remote procedure call, and here the remote procedure call means it's the way we normally carry out the local procedure calls. The way we do it, it's similar to that, but here the function call or the procedure that need to be performed is available in a remote machine, not available at not available in the local system and all, right? So here the remote procedure call, the way it happens is that for that actually here we'll make use of the stubs. The stub means actually here these are the ones which used to like they used to here the stub means actually it's kind of methods where they contains the they try to identify that where this procedure call is available or where the who handles this procedure call. That will be the job of a stub. And not only that, after I identify that and whatever the required parameters that need to be passed to that particular procedure call, so that will be properly packed by using these stubs and all. Like there will be stub at a client side, and at the same time there will be stub at the other side also, wherever the procedure is available, right? And here, suppose the client executes it invokes the remote procedure call, and that will be first reached to the stub at the client side, and then the client will see that the procedure call, and then it will first check that where the procedure call will be run, where the procedure is available and all, and then afterwards, then we'll come to know that what is the port address of that one, and once you got that port address, then the client side stub will pack the parameters, because to run the procedure and all in a normal local procedure call, when you call a function, you see that you are sending up parameters as arguments to the function and all. Then those parameters will be used within the function and it generates some output, right? Similarly here also in case of remote procedure call, so whatever the parameters that are required or need to be passed to that particular procedure, so all those parameters will be packed and by the stub at the client side. And here the packing the parameters is known to be marshals. It means that because here, because you are running you are executing a procedure or a process at a remote machine, and the machines are at a very remote machine there, the client machine and the procedure where that is available, those machines are very different, and they may have the different configurations and a different way of representing the data may happen. Like for example, yeah, here in the local machine, you may following the Little Indian, for example, whereas there you are following the Big Indian style, for example. So likewise, the way of encryption ways, methods, and the way of data representations, they may be different at different machines and all. So therefore, here what is be performed here is that the client side stub, it just whatever the parameters that were need to be sent, those parameters will be transformed to very like unbiased style, like which is like the like they're transformed to a form where that is a neutral to the system platforms and all, and then it will be sent to the other end. The other end where the parameters whatever is sent by the client stub and all, so they will be again converted back to the suitable for the configuration of that particular remote machine, right? That means, for example, as I mentioned here, we have a Little Indian style is required here in your local machine. So now actually here you are sending the parameters and converting Little Indians to the neutral one. And again, you are sending that. And those parameters, whatever received at a remote server and all, and there again, that has to be those data items and whatever, they have to be converted back to the conventions that is followed by the remote machine, that is a Big Indian, for example. So they will transform to Big Indian style, and then the procedure will be executed there, right? And then out of the outcome is that output will be again sent back to the sender or to the client. So for this, actually, you can able to see here, yeah, these things I just mentioned. And here you can see this is the diagram. This used to be like with which you can able to see that how the remote procedure call will be executed. So for example, here is a local client or just a local machine, and you want to perform some RPC here. So the RPC will be invoked here, and that will be first interact with the local stub, and the local stub will not know about where that procedure will be exist and all. So therefore, it will contact the server, and the server will find out that where it is available, like not to be matchmaker or something, and where that procedure is available and what is its port number and all. So that will be known by this server, and then the port address of this particular the destination or the procedure. So that will be written to the client again, and then now the client has come to know that, yeah, where that procedure is available, what is the port address, which machine it is available, all the details are known here. And then the kernel at the local machine, now it sends the parameters, nothing but marshalling the parameters, and then all those parameters along with the required the data, it will be sent to that particular port, and there it will receive the other destination end. From that port you receive the parameters that are required for execution of the procedure and all. Then at the local at the destination machine, remote machine, the procedure will be executed, and whatever the outcome of that particular procedure, and so that will be again sent back to the client and all. So that way here it's just execution of a procedure call at a remote machine. And since you are executing a procedure call at a remote machine, where that first of all you should be know about actually where that remote machine is present, and what is that in the remote machine there are again several processes will be there, and in that which process is responsible for execution of this particular procedure call. And so that information has to be come to know will be received, and after knowing that, then we'll try to send that information to that particular procedure call, and that procedure will be, and again the parameters whatever you have sent, and again those parameters will be again transformed back to that particular machine's conventions and configurations. Then the procedure will be executed there, and then whatever the outcome will be there, that outcome will be returned to again the client machine and root. So this way you can do that. But here in establishing the remote procedure call to perform this one, here first of all the client will contact with the server, and when you contact the server and all, sometimes no the message will be missed out or received erroneous. Then again the multiple times has to be contacted. So during that time sometimes the duplicate connections may happen. So therefore when you are performing the remote procedure call, you need to ensure that the connections should be established properly, and at most one connection has to be established, and with that connection it will come to know about the information about the server and support. So these things, that is the one problem with the RPC and all, because in the normal local procedure calls and all, local procedure call will rarely fails, but the chances of remote procedure call to fail will be there is some chances where the remote procedure call may fail because of these things, all these things, involvement of these things and all. Okay. Then coming to the pipes. So here the idea of pipes is much earlier compared to the ones whatever we have discussed, like this RPC and other things. These pipes are the earliest way of communication between the two processes and all. So usually, yeah, we'll see that these pipes are mainly meant for communication between the parent and child. The pipes are initially started to have a communication. Suppose the parent want to communicate, a parent want to send some information to the child, or child want to respond or something, or to have a communication between the parent and child. So initially with that requirement, the pipes have been initialized, or pipes have been started, or they have been started, and then later on these pipes have been extended for even the communication of process between the across the systems which are available or which are placed remotely also. So yeah, you can yeah, we'll see this anyway now. Yeah, it needs another 5 minutes, so we'll stop here. But it's not difficult at all. We'll discuss that. We'll continue that in the next class. The next 5 minutes of the next class, we'll discuss about this, and then afterwards we'll move on to the extension of process, like the threads, concept of threads and other things. Okay. So let me stop here, and So yeah, I'm stopped recording.